Hello, my name is Lotus Fai, and for my embedded OS final project, I decided to create a mobile application that interfaces with a Raspberry Pi, and it also does fall detection and a plus trajectory that it thinks your phone took. So my project was creating an application on a phone that actually communicates with a Raspberry Pi, and I currently have a 7-inch touchscreen display over there. And the application I've created from the UI perspective is very simple. It perpetually tries to connect to the Raspberry Pi via Bluetooth, and if it doesn't connect, it just keeps retrying again. Uh, and these are the hardware values that I'm reading from the phone, the rotation, accelerometer, and then using those, I'm able to compute actual current velocity, which actually updates really accurately. Now, after we've launched our Android application, we can see it's currently running. We move on to launching the Raspberry Pi server, and in the server, once a connection is made, it starts going through the reset sequence, which is what we're currently seeing. Once the GUI is displayed, we're then able to toss our phone, as you can see here, and once a successful toss has been done, it displays a lot of buffer data, so let's just fast forward to that for a little bit. And then this usually takes about a minute, which is pretty much exactly almost how much time it took here. And then it starts the actual animation sequence for what it predicted the fall to be. And during this animation sequence, it starts updating pitch, roll, and the actual position of the phone. And this animation sequence takes about 0.1 seconds per frame, and this was done on purpose. You can essentially display it in real time if you want to, but the actual lag kind of like shows what the change is over time, which I thought was pretty cool. And the pitch and roll values that you guys are seeing here are within ranges of negative 360 degrees and positive 360 degrees, and this is it pretty much predicted that the fall was about half a meter, which is pretty accurate. And yeah, that you can move it around, see what's happening with this trajectory.